the first derivation in this chapter. Okay. So when I take a conductor, don't write the heading, leave some space for the heading. We'll give a name to it after we derive at that value. Okay. Let's say you have a conductor which has the free charges flowing inside. The free electrons which are flowing inside it in a random direction. This is U1, this is U2, this is U3, so on. If you take this to be negative, it will be UN. If this is going to be positive charge, this is going to be negative charge. Okay, I'm considering it to be positive and negative. As soon as you connect this potential source, there is an electric field that is generated from the higher to the lower potential, right? Now, what is happening in the initial condition? U1 vector plus U2 vector plus so on till UN vector the whole divided by n is equal to 0. We know that the average initial velocities, the average of initial velocities of all these electrons put together is going to give you a null vector. Am I right? So, when this is the scenario, as soon as you connect this potential source, what is going to happen? After the connection of potential source, what will happen? Due to that electric field, there will be a force experienced by the charged particle, which is going to be E into E. Now I'm adding the negative sign. So E into E with the negative sign. Can I say that this value is equal to mass into acceleration? Which implies acceleration is going to be equal to minus of E into capital E divided by M. Accepted? So what is happening basically? Initially, each electron was possessing the velocities U1, U2, so on till UN. And they started accelerating at the same rate. Okay. So when they were accelerating at the same rate, can I say that the value is going to change from U1 to a higher value? Obviously, right? Some object is accelerating, then it is supposed to have an increase in velocity. So if I talk about the final velocity of the first particle, can I say V1 is equal to U1 plus A1 into T1? But the correction I need to do here is there is nothing like A1, right? Because the acceleration of each charged particle is the same, right? So from here, what is it I can conclude? V1 will be equal to U1 plus minus E into capital E divided by M into T1. Makes sense? The only thing that I need to do here is I need to write it in the vector form. Similarly, if I take for the second particle, it is going to be V2. So V2 will be equal to U2 plus, I'm not writing A2. So I'll strike off this A1 also. It is not there. You will ensure that you should not write it. Okay, I've removed it. Okay. U2 plus A into T2. So if I write them in the vector form, it is going to be something like this. So what will I write here? Which implies V2 vector is equal to U2 vector plus negative of E into capital E as a vector, the whole divided by M into T2. Makes sense? So like this, if you keep on writing, then what is going to be the value of Vn vector? It is going to be Un vector plus A vector into Tn. Right? So here I am writing the time to be different because each particle will take different time to reach the same acceleration. Okay. So Vn vector is equal to Un vector plus minus E into capital E vector, the whole divided by M into Tn. Now what I'm supposed to do is I'll add all these values. Right. So when I'm going to add all these values, I will get V1 vector plus V2 vector plus so on till Vn vector is going to be equal to u1 vector plus u2 vector plus so on till un vector plus minus e into e vector by m into what am I going to get? I'll get t1 plus t2 plus so on till tn, and this is going to be the value. Right. So what I did here is I added all of them on the left hand side and the right hand side. I added the corresponding values. Right. This is where I want you to observe now. So basically what we are getting is v1 vector plus v2 vector plus so on till vn vector is going to be equal to u1 vector plus u2 vector plus so on till un vector plus minus e into capital E divided by m into t1 plus t2 plus so on till tn. Right. Now I will divide it with capital N on both the sides. So when I divide it with capital N on both the sides, I converted the vector sum to average vector sum. So can I give a name to this called as average final velocities? But we know the fact that the average of initial velocities in the vector sum is going to be a 0. Right. And if you see, I have taken the average of time. So each of them is given a specific name. This is given a name called as drift velocity. This is what is called as drift velocity, which is written as v with a subscript d and a bar on top of it, is equal to minus e into capital E divided by m into the average of all these values, the average of all the time taken by each particle to reach the same acceleration, which is given a name, which is given the symbol tau, and the name of this symbol tau is called as relaxation time. It's called as relaxation time. So relaxation time basically in terms of electrons means it is the time between two successive collisions. So the time that is existing between two successive collisions is what we call it as relaxation time. Let's visualize what I'm trying to say here is this first particle, there's the second particle. Okay. The first particle is coming and hitting the second particle, going back again. So first collision has happened. Right, going back again it will come and hit no. So the time that is existing between the first collision, going back again and coming back for the second collision is what we call it as relaxation time. Are you able to understand? Right? So this drift velocity is mathematically represented as minus e into e vector divided by m into tau. So the name of the topic is drift velocity. Which is represented by the symbol Vd. So drift velocity is minus e into e vector divided by m into tau. Right. So how did we get this drift velocity? Which term was replaced? We replace the average of all the final velocities. So when you say the average of all the final velocities attained by the particles under the influence of electric field. This average was attained only because of the electric field. If that was not there, the particles would have not experienced acceleration. If that is not there, then there is no concept of final velocity. So the average of all the final velocities achieved by the particles under the influence of electric field is called as drift velocity. If you look at the significance, right, this term will give rise to another concept called as mobility. Because this drift velocity has something to do with the mobility of the charges inside. When I say mobility, if you try to understand from the basic English, what does it state? the extent to which the charged particles are able to move, right?